How's it going, everybody? Over the last couple weeks, I've been working with some students on the traveling salesman problem, and each of them have brought the same feedback that the YouTube videos are not extremely helpful. So I was hoping I can make a short video that will be able to help you answer some of the questions that they had. So let's jump right into it. This information here is the distances between each of the NBA stadiums throughout the country. So the purpose of this assignment is we want to find the most efficient route of how we can visit each of these starting and ending in the same point. So I'm going to zoom in a little bit so you can see my tables. Let's jump in. We have the name of the stadium, the stadium number, the distances, and the stops. And it's important to go in this order just because of how I'm going to show some of the formulas later on here. So let's go ahead and we're going to put our stadium numbers 1 through 30. And then we're going to copy and paste that into our stop numbers. And so here for the names of each of them, we can just do a quick VLOOKUP, which we're going to reference the cell to the right of it, which is covered up. And then our table array here, we want to go into our data and just highlight these two columns. So this way we can, we're going to absolute reference that by clicking F4, and then we're going to do our column index as 2, meaning we're going to search through the second column. So it's going to pull the name associated with each of these different stadium numbers. We're actually going to go one further, and what I'm going to do is put our final stop here. So for example, Seattle. We want to start and end in Seattle. For the distances, we're going to create an index function, and here we want to, it's not going to let me zoom out while I'm in the function. So let's go ahead and zoom out. I'll zoom back in on the code here in a minute, but let's do an index, and we want to take the array, just the information, not the labels. And we want to absolute reference that by hitting F4, comma. We want to take the second stadium and the first stadium. Again, I'll pull up the code here for it. I want to zoom back in now so you can see my table. So it's just up here is the code. And then we want to, since we have an absolute reference on it, we can go ahead and drag this down. We're going to stop at the 30th station. What that last number is actually doing is indexing the distance between Washington, D.C. and Seattle. So now something that's important for the solver itself, we need to pull the set objective from a cell that is created by a function. So we're going to create a sum function and sum all the different distances we'll need to travel, which currently it shows about 36,000. But one of the main criteria is we want to start and stop in the same city. So we want to check that our starting point is in Seattle. So what I'll do is we'll put the 27 there, which is the number of Seattle. Then we want to create an if statement that says that if this first stadium equals 27 or Seattle, we want to return 1, else return a 0. So obviously it's going to return a 0 because right now we're in Atlanta as our first stop. Now let's click into the solver and change our set objective here to this sum value. Okay, so then we want to set it to a minimum value, and we want to do that by changing just the stadium numbers. And we don't want to change the last stop being Seattle, so we'll just go through the 30 there. Now we want to set a constraint, a couple of constraints. Cell values, we want to change, or we want to set each of these, so that's 1 through 30, and we want it to be diff, which means it's all different. So let's go ahead and click OK. We're going to add another one with the cell reference with this if statement we just created to check that Seattle is first. So let's go ahead and click equal, and we want to set that to 1. Click OK. We want to set this to an evolutionary solver. And you jump into the options. This is personal preference on how long you want to run it. Let's go ahead and just say we want to run it for 20 seconds. Click OK. Everything's looking good, so let's click solve. And here on the bottom, you can see that it's actually changing the value of the cell. It's not doing it in the spreadsheet quite yet. But here we are at 9,400 where we were at 36,000 miles. So it's a huge jump already. Here in a minute, at the end of our 20 seconds, it will rearrange these. So the solver will actually give different values depending on just how the machine's running. So do we want to continue? Let's go ahead and continue. But the machine sometimes will spit out a different value, so you might not get exactly this as you're running through this, but you'll get pretty dang close. So if you look, you can see that it's changed up the orders here. And we can't see the top, so when it gets to the end, But we know that Seattle is there at the ending point, and then I'm going to go ahead and click escape, and we're going to click stop. And so it's not quite at the end, but you can go ahead and continue running it, and it'll get you the best solution that it will. So here in our check, you notice that it's put Seattle at first so that that condition is met as a number 1. So that's how you can go ahead and write code to make sure that you're starting and ending in the same location while still going to each of the different stops. Now let's say your teacher puts the criteria that you need to, as soon as you get to Dallas, you need to go directly to Golden State. So those are going to be stations 6 and 9. So what we want to do, let's create a VLOOKUP here, and we're going to look up the value 6, which is Dallas. And then the table array, we want to search these 3 columns down through all 30 stops. We want to pull from the column index for number 3, and I'll put a false just to make sure that it pulls the exact value. And so what this is looking for, we're going to find which stop number in column 3 is Dallas. So right now it's 23, so when we click enter, it's going to show up as 23. So Dallas is the 23rd stop, and here we want to create an if statement, and then we want to index in the array of stadiums, and we want to, for the index of this plus 1, so what we're doing is we're saying if we want to take the Dallas stop and add 1 to it, and if that one equals 9, being Golden State, then we want to return a 1, else return a 0. And we'll go ahead and enter that. Obviously it's still not true because Dallas and then Golden State is a few stops down. But what we can do is we can jump back into our solver, and then we can add a constraint for it. And our cell reference is the one we just created the if statement in, and the same as when we're checking for Seattle, we want it to equal to 1. Go ahead and click that. Nothing else has changed, so we can go ahead and solve. And it's going to run through. It's breaking down the numbers, but now it has 2 different criteria that it needs to meet, so it should work a little bit quicker. I don't even know if it will take the entire 20 seconds. It's going to not quite be the 9,000 because we have the specific requirements for it. Let's go ahead and stop. You can click continue if you're looking for a more exact solution. But here you can see the Dallas to Golden State, we have our criteria as 1. And so Dallas is stop number 7, and then Golden State is stop number 8. So it meets that criteria. So that's just some quick ways. There's several different ways to do that. These are the ways I found to be most efficient. So go ahead. If you have any questions, feel free to comment. If you have other questions, other problems you'd like me to solve in future videos, feel free to comment those as well. Go ahead and like this video and subscribe to my page. I'd love to talk with each of you later. Have a good one.